Hello, you're welcome to my YouTube channel. Thank you for stopping by. Today we are going to be answering exam style questions on trigonometry, especially non-right angle triangles. Please note, we only apply Pythagoras theorem and SOHCAHTOA to right angle triangles. So long as the triangle isn't a right angle triangle, then you should use either your sine rule or your cosine rule to answer such questions. Now, you might be wondering when to use which one. I have a video. I'm leaving the link in the description box for you to watch to determine which rule to use for which question. Just a quick recap of both rules. We have the sine rule here and the cosine rule here. But the very first most important thing is for you to label your triangle appropriately. This is side A, B, and this is triangle ABC, meaning this is angle A here, and the corresponding side is opposite it here as side A. This is angle B here, its corresponding side is right here as side B. And finally, this is angle C here, and its corresponding side is down here. All right, so let's get right into our questions. Question number 1. A triangle has sides of length 11 centimeters, 10 centimeters, and 9 centimeters. Calculate the largest angle in the triangle. The very first thing you need to do here is to draw the triangle so you can easily see the shape you're trying to calculate something for. So I'm drawing my triangle here. Doesn't have to be anything perfect. All right, I'm labeling this A, B, and C. Remember the labeling notation. If this is A, this will be side A. If this is B, this will be side B. And since this is C, this will be side C. I've been told that the triangle has sides of length 11, 10, and 9. So just in the same way I have labeled them, I'll just go, this is 11 centimeters, this is 10 centimeters, and this is 9 centimeters. Now I have something to look at. I've been asked to calculate the largest angle in the triangle. The largest angle in this triangle will be the side, the angle that corresponds to the longest side. Let me say that again. The largest angle will be the angle that corresponds to the longest side. The longest side in this particular triangle is the angle at C. So this question is asking us to find the angle at C. Since it's an angle we are looking for and we have been given 3 sides, the appropriate rule to use will be our cosine rule. Now, finding an angle with cosine rule states that the cosine of C will be given by A square plus B square minus C square over 2AB. Now, the cosine formula will be given on the formula page, but it's just good for you to know how to write it down without even looking at the formula page. The square of the first side plus the square of the second side minus the square of the corresponding angle you're looking for, divided by double of the two other sides, double of the product of the two other sides. All right, so let's just substitute our values. Oh no, let's do this first. So C will be given by cos inverse of A square plus B square minus C square over 2AB. Now we can substitute. Okay, so it will be given by the cosine inverse of what's our A? Our A is 10. So I have 10 square plus what's our B? 9 square. And our C is 11. So it will be minus 11 square over 2 times 10 times 9. Okay, and this will give us cos inverse of 100 plus 81 minus 121 over 180. So really we are looking for the cos inverse of 60 over 180. If you punch that on your calculator, you're going to have 70.52 and quite a number of other figures. The requirement is that you give your answers in degrees to one decimal place. So our final answer here will be 70.5 degrees. Okay, let's move on to the second question. Here we are told to calculate the obtuse angle X in this given triangle. Again, for convenience sake, you could label your triangle and we'll have A, B, and C. So here we are being asked to find the angle at A, which is angle X. What do we know? We know two sides and an angle. And we can see that the 8 centimeters corresponds to the 39 degrees. So we have a corresponding pair and another side. All right. Given this information that we have, it is appropriate for us to use the sine rule. Okay. So using the sine rule, we'll know that sine x over 12 will give us sine 39 over 8. Remember, the sine rule says a over sine A over A equals to sine B over B equals to sine C over C. So we have picked the pair we need here. All right. So it means that our sine X will be given by 12 sine 39 over 8, which means that X is the sine inverse of 12 sine 39 over 8. I always advise students to do this. Don't approximate your answer anywhere yet until your final answer. So just punch this directly into your calculator. When you punch this into your calculator, you're going to get 70.7311 and so on. But there is an extra piece of information given here. We are told to calculate the obtuse angle. This value is acute. Acute because it is less than 90. An obtuse angle is an angle that is greater than 90. So really, even though we have gotten 70 here, what we need to do to find its obtuse version is to say 180 minus that answer we got, 70.7311. When we do that, we are going to have 109.2688 and so on. Again, since it's an angle, angles are supposed to be provided to one decimal place. So our final answer is going to be 109.3 degrees. All right, moving on to the next question. In this particular question, we've been given 4 different things. We know all the 3 sides and one of the angles. And we have been asked to calculate angle ABC. Angle ABC. It means we're looking for the angle at B. That is what they mean by angle ABC. To calculate the angle at B, since we know 4 things about this triangle, we could either use our sine rule or our cosine rule. I'm going to opt for the sine rule. All right. So to calculate angle ABC, I'm going to have sine B over B should be equal to sine A over A, and then our sine B will be given by B sine A over A. And then our B will be given by sine inverse of B sine A over small letter a. Now let's substitute these our values in. This is going to be the sine inverse. What's our B again? Our B is right here. This is B, this is A, and this is C. Okay, so our B is going to be 29.5 sine A. Our angle at A is 51.6 divided by A. Our A is 35.3. When we punch this in our calculator, we end up with 40.914 and a couple of other digits. Again, we should give our answer to one decimal place. So our final answer is 40.9 degrees. I want you to try out the same question by using the cosine rule. Please give your answer in the comment section. Thank you. Have you subscribed yet? Please do. Now let's move on to the final question here. We have been asked to calculate the area of triangle ABC. Area of triangle is given by area of triangle is given by 1/2 AB sine C. Now, don't be so fixated on, oh, it has to be A, it has to be B. What they mean is that you need to have the product of two sides and the sine of their included angle. The area of the triangle is half the product of two sides and the sine of their included angle. What do we mean by the included angle? Let's go back to our diagram. The only angle given in the original diagram is 51.6. So this angle is the included angle to side AB and AC. So this is the pair we are going to use. This will be our own formula for this particular question. If you want to write it correctly, it's going to be half. Since our two sides that have the included angle are B and C, so our own formula will be half BC sine A. All right, so let's just substitute our values. 1/2, what's our B again? Our B is 29.5. Our C is 45. And the sine of angle A. Angle A is 51.6. Okay, so we evaluate this and it turns out to be 520.176 and so on. To three significant figures, our final answer is 520 centimeters square. All right, so that is the answer to the area of the triangle. Thank you for watching. I hope you understand it. If you have any questions, feel free to leave it as a comment in the description box. And don't forget, you're supposed to attempt this particular question, that is calculate angle ABC using the cosine rule, and leave your answer also in the comment section. Thank you very much for watching. See you in the next one. Bye.